is we have to look at this. We said if we were looking at Yolanda's equation and she charges $5.50 an hour, we said we could write y equals 5.5x. You didn't have that, please write it down. Write your next equation, and our other equation is going to be for Marissa. And Marissa is getting paid 50 cents an hour with a base pay of 20. So she is y equals 0.5x plus 20. Now this one says, when does Marissa charge less? And this one says, when do they charge the same amount? So if I'm looking at them charging the same amount, I need to make sure I look at Yolanda's equation, which was y equals 5.5x. I'm only going to write down how much she's getting paid, which is 5.5x, equals Marissa's equation, which was 0.5x plus 20. And now I'm solving this. So this is my substitution. So go down to number 3 and write this down. So as you are writing this, we need to get all the x's on one side, and we're going to subtract 0.5x from both sides. So in number 3, I now have 5x equals 20, which means when are they going to be getting paid the same? And I divide both sides by 5, and I would say x equals 4 hours. Well, this one said, for what times does Marissa charge less? So if we were writing about that, the only thing different would have been when x is greater than 4 hours. So you could have said when there was more than 4 hours. You could have said 5 hours or more, anything along that line. Here we are reading this and it says Raj is 1 year less than twice Sarah's age. Tony is 2 years less than 3 times Sarah's age. If Sarah is S years old, we have no idea. She could be 5, 10, 15. And Raj is R years and Tony is T. So suppose we're going to write Raj's age, and we did this one in class last week. We said twice Sarah's age means 2s, and less 1 year means 2s minus 1. If you didn't have that for R, please write that down. As we are taking a look at Tony's age, Tony, it said, is going to be, as we look at this, as we look at Tony's age, it said Tony is 2 years less than 3 times Sarah's age. So if we are looking at that, 3 times Sarah's age is going to be 3s, and it is 2 years less than that minus 2. If you didn't have that, please make sure you write that down. So now as we are taking a look at our equation, it says that there are 3 ages total to 21. So that means Sarah's age, which is S. But instead of using Raj's age, we know R was equal to, we're going to write 2s minus 1. So we're substituting it. And instead of T for Tony's age, we know Tony's age is equal to 3s minus 2. And all 3 of them had to total to 21. So now I'm going to add my like terms. So as I am looking at this, I'm going to add s plus 2s plus 3s. If I'm adding those together, Sky, I should have how many s's? Okay, so I got 1s plus 2s plus 3s leaves me with 6s. I have a negative 1 and a negative 2, which if I'm adding those together, Josh, it's going to give me a negative 3. And that was equal to 21. I'm solving this, so I'm going to add 3 to both sides. And I get 6s is equal to 24. So if I'm looking for Sarah's age, I'm going to divide both sides by 6. And Sarah's age in this case is going to be looking at 4. So Sarah was 4 years old. Can I find Raj's age by replacing the s with 4? So I'm going to take 2 times 4 minus 1, 8 minus 1, which means Raj has to be equal to 7. So far those two together total to 11 years, right? So by just thinking it through, even without substituting in to find how old Tony is, if those two total to 11 and their 3 ages total to 21, we would think that Raj has to be 10, and we could check. 3 times 4 minus 2, make sure you're writing this down, Ben, is going to be equal to, if we look at that, 10. So we have 10 years old. So our lesson today is going to be more about writing than solving. I'm not going to be that worried that you solve any of the equations tonight. You're just going to be asked to write them. So we're going to read through this next part about Melissa and Trevor. They're selling candy bars to raise money for a class field trip. Trevor sells one more than 5 times as many as Melissa. Melissa not doing very good at selling, right? She hasn't sold that many compared to him because he sold 5 times more, right? And together they sold 49. So we have to write an equation. So the first equation I'm going to be thinking about is a lot of times people always want to use X and Y, but sometimes it makes sense to use the letters of like the people's names. So instead of using X and Y, I might, as I'm looking at this one, go, oh, Melissa plus Trevor, how many candy bars did they sell altogether? They sold 49. So one of your equations a lot of times is going to deal with how many. So if they say these two things together were 49, it is a very simple equation. Marissa plus, in this case, Trevor equals 49 candy bars. Could you have used X and Y? Yes. Okay. The next statement says that Trevor sells one more than 5 times more. In my second equation, T equals, what's 5 times what she sells? If she sold M, 5M, right? So 5M plus 1. This is a perfect substitution. So when you're thinking about the quiz that you took on Tuesday, at this point, this would be what I'd circle. And I'd put that in place of the T. So it says solve this, if we are looking, we're going to have M. Instead of T, we're going to write 5M plus 1 equals 49. We're going to continue adding our like terms. We have 6M plus 1 equals 49. We subtract 1. 6M equals 48. And we knew Melissa didn't sell that many. Melissa sold 8. We get 8, we divided 48 by 6, right? To give us 8. So now I know that she sold 8. If I'm going to find how many he sold, I'm going to take 5 times 8, which plus 1. So Trevor sold 41. Now, the homework questions tonight, the only thing I'm going to ask you to do is to write these 2 equations, okay? So each one you're going to be asked to write them. So as you look at the rest of the week, as we are looking at this, as we look at so we're going to take a look, and so I will tell you that on the test next week, Thursday, okay, you have to write 4 equations, and then when you get back your quiz today, you're going to see that the F12 is more practice. And some of you that maybe didn't turn in 32 and 34 from before, you might want to go back and do those for the practice and make sure. You might want to go back and watch the videos. But in this case, if we are looking at the number of CDs, we might write an equation and say T equals, so Tom had, what did he start out with? How many CDs? 30. Plus, he's adding how much each month? Plus 1 CD, so 1 C, right? And Nina's equation is that she started with how many CDs? She started with 18. And each month she's adding 5 C. And this is as simple as you can read this as your answer. Now, if you turn to the back, you might see that they wrote this as y equals 1x plus 30. And you might see y equals 5x plus 18. Are these the same equations pretty much? Yes. So why would I maybe use T and N? Because I'm talking about Tom and Nita, right? So I might use things that make sense for the problem. if you would please right now turn in your notes, we are going to be on lesson F10 on page 22. So in 22, solving the real world, it says the number of right and left-handed students in a math class. So the number of right-handed is 9 times the number of left-handed. So already we're thinking, are there more right or left-handed people? There's more right-handed people, right? And it says there's a total in class of 30 people. So let's go with our total number of people in class. And it makes sense to me in this one to go R for right and L for left. And how many total people were in our class? 30. And what did I know about the right-handed people? R was equal to 9 times the left. Those are my 2 equations. That's all you're going to be doing on that part of the test. Now, if we were going to answer the question for how many were right-handed, this is going to be a perfect, right, substitution. Because I'm going to replace R right here with 9L. And look how quickly you could actually solve this. 9L plus L equals 30. That means if I am solving this problem, Izzy, I'm going to have what as I'm looking at this? 9L plus L would give us 10L equals 30. And Nick, if I'm solving for L, divide both sides by 10 and get what? 3. So how many left-handed people in class? 3. Now, in my head, I might be thinking, oh, I could multiply by 9, or I could subtract from 30. But I might not even have to show my work, and I could get that there were 27, right? 30 minus 3 gives me 27. 9 times 3 gives me 27, okay? On the next page, Elsie, would you please read in the notes about our 2 trees?
A plant nursery is growing a tree that is 3 feet tall and grows at an average rate of 1 foot per year. Another tree at the nursery is 4 feet tall and grows at an average rate of 0.5 feet.
So start by please writing tree 1 and tree 2. We are going to be looking at Y being the height. And we are going to be X is our years that it's growing. So tree 1, if I want to write that, I'm going to start with Y equals, Liz, what was the starting height of tree 1? 3 feet. So 3 plus, and each year, Betsy, is growing how much for tree 1? 3 plus 1x, right? 1 foot a year. Ben, are you writing? Okay, try it. If we look at on tree 2, Y, the height of that tree started out where? 4. Plus, it is growing how much, Reed? 0.5, so I'm going to put 4 plus 0.5 or 4 plus 0.5x? 0.5x. We're not going to solve this one. Could you solve this one? You would put tree 1 equal to tree 2. So if you need to practice solving, you might put down 3 plus 1x equals 4 plus 0.5x. If you were looking at this one and you were solving it, we're not going to go through that work right now. You should have come up with 2 years for an answer. I'm not going to go through the work of doing that, but you should be able to solve this one. I want you to notice they used H and they used Y for years. Could you use any variables? Yes, but you just kind of want to define what they are. So, the next page, as we are reading. Luke, go ahead.
At a local fitness center, members pay a one-time $20 membership to give them $3 for every aerobics class that they attend. Non-members pay $5 for every aerobics class.
So we are asked to write a system. So our equations are going to be the members equation and the non-members. And what we are really looking at as Y, and sometimes people like to use the letter C because it's my cost. It's how much money I'm spending, right? And then instead of using X, they might use A because it stands for what classes? It stands for my aerobic classes, right? So I just want you to be aware that when you write these, you always have to have 2 variables. I don't care what your 2 variables are. They kind of need to make sense to you. So in need for this one, when I'm looking at it, I might think of my members. And if I'm a member, I had to first pay what, Jocelyn? What did I have to pay to be a member?
$20.
$20 fee, right? So my cost is 20, plus then once I go to each aerobic class that I'm taking, Soraya, it costs me how much if I'm a member? So 20 plus 3 or 3x? Or 3a? 3a, okay? 3 times each class. So if I only go as a member to one class in that time I have my membership, I pay $23 for the class, right? 20 plus 1 class. If I go to 2 classes, 20 plus 6, right? If I go to 3, I'm at $29. Does that make sense, right? If I'm a non-member, I need to write my equation for my non-member. Ian, what are you thinking? How much are we paying if we're a non-member for each aerobics class?
5.
So 5 A or just 5 or 5 plus something? What do you think?
5 plus. 5.
5A, 5 for every, 5A, right? 5 times A, 5A. So if I'm a non-member, 1 class $5, 2 classes 10, I don't go again, that's a much better option, right? That's where clubs kind of get people where they start paying money and they think they're gonna always go and then they don't go, right? So this might be your better option unless you're gonna always stick to your plan, right? We are not gonna solve this. Would this one be hard to solve also, if you were looking at it? No, you would replace this C, right, with 5A. You would have said, oh, 5A equals 20 plus 3A. Put all your A's on one side and it's not that hard to solve, okay? We're not gonna do that right now. Because I want you today in class, we're gonna get back your quizzes, and I also really want you to get at least maybe 5 or more of those equations written. So, looking at this one, ready? Go ahead, read.
Mike and Kim invest $10,000 in equipment to print yearbooks for school. Each yearbook costs $5 to print and sell for $25. How many yearbooks does they sell before their business breaks, even when income equals expenses and you make zero profit?
So, a break-even point for any business is when those two things, everything you put into it, your expenses, is equal to when you start making money, right? So those two things have to be equal. So, I want you to be thinking that we need to write an expense equation, and we need to write one for income. Now, you probably won't see, I don't think the one on our test is a break-even, but you will see quite a few of these next year in algebra because they do a ton of break-even problems in algebra. So when you take a look at this one for our expense, well, we again might be using C because C stands for my costs or my money, right? How much money I've spent. And then we're looking at yearbooks, so I might use Y because that's going to be my, how many yearbooks I sold, right? So I'm going to use C for cost, I'm going to use Y for yearbooks. My expenses, my cost, is equal to, what's one of my expenses when I take a look at it, Evelyn? What do you think? How much? $5 a yearbook, so 5Y. Did I have any other expenses that I have to add to that? Not the 25, no, that's how much when I sell it, that's how much I'm charging for them. I have the 10,000. Now, in the last class, I had a couple people tell me 10,000 Y. That doesn't make sense. Like, tell me 10,000 per yearbook, right? So 10,000 is this number by itself. That's my y-intercept, right? That's my start point. And the slope, $5 per yearbook. So now I'm looking at the income, right? So if I'm looking at the income, and I'm looking at that one, the income for this one, what am I going to have, Ellie? How much am I making per yearbook? So 25 Y. This again could easily be solved by taking 25 Y equals 5 Y plus 10,000. Let's solve this one. So let's find out how many yearbooks we have to sell. How do I get all the Y's on one side? Subtract 5Y. When I do that, I get 20Y equals 10,000. To me to solve, I'm gonna do what? Jimmy, thank you, divide by 20. And if I'm looking at that, using my calculator if I need to, or taking 10,000 divided by 20, I should have to sell how many yearbooks at my school if I'm looking at this? To break even? 5. Let's think if 5,000 makes sense.
500.
Take 25 times 500 on your calculator.
25 times 5,000.
So if I want to check, right, I could put, 5 times 500 plus 10,000. And I'm trying to see is that equal to 25 times 500. Okay? So, quiet please. So as we are taking a look at those, my answer would be in this case that 500 yearbooks. Top of the next page, we got 2 more equations to write. Okay? So, as I am taking a look, Lee, would you please read for us?
Yeah. The measure of one acute angle in a right triangle is 4 times the measure of the other acute angle.
So if we take a look at this, they have this right triangle down here. Please put your right angle. That's how many degrees? 90. And we don't know what this angle is, so we're going to call this one X, and we're going to call this one Y. Do you agree that these are both acute angles?
Yes.
Okay, both less than 90. And in a triangle, what do I know about all 3 angles in a triangle? That X plus Y plus 90 equal, not 360. How did the 3? 180. Now, some people will write this because this is my 3 angles, right? Does that make sense to you? These are the 3 angles in my triangle. But there are a lot of people that would prefer to write an easier equation, and they'll go with this. That the 2 angles together only have to equal only 90, right? Subtract 90 from both sides of that original equation. So I will have a lot of people use this equation on the quiz or test when they're doing it. Would this one be correct too? All 3 angles add to 180? Yes. So both of these are equivalent. One just has a few more numbers in it, okay? So next, we want to take a look. And we want to go back to that statement, Ava, where it said, one acute angle is 4 times the other. Which angle do you want to be larger, X or Y? You just have to choose. X is going to be larger. So we're going to have all of our X be our larger angle. How many times more is it than Y? So X equals 4Y. Second equation. And again, if I was solving this, I am going to replace the X with 4Y. 4Y plus Y equals 90. 5Y equals 90. I'm going to divide on both sides by 5, and I get one of my angles. Okay? I get the Y. Then I'm going to take it times 4 to get the other angle. Okay? So you can finish solving these if you like. My key thing is writing the equations. We have one more that we need to take a look at. Earth, if you would read that last equation for us.
The theater club sells a total of 101 tickets in its first day. A student ticket costs $1 and an adult ticket costs $2.50. Total ticket sales are $164.
So the first thing I want you to think of is we are going to look at the tickets sold. And then we're going to look at the value of the tickets. And this will go for any of ours. Like there's one today that you're going to see, it's about people, passenger or coach train or something like that. Or they talk about the ticket. So when you look at this one, we want to start off. And how many tickets or did we actually sell? We sold 101. And if we are looking at that, what kind of tickets did we sell?
Student tickets and adult tickets.
Student and adult. So adult and student, right? So my student is going to be my S, and my adult tickets are going to be A, right? A plus S equals 101. So Sam, I need to find the value of each of those. So the value of my adult ticket was how much?
$4.
Wait, the value of the adult ticket was how much? Keep reading.
Oh, $2.50.
$2.50. So I'm going to put 2.5A plus the value of my student ticket. So here is
1.
So I have 1S equal to my total value of money spent, Ben, which would be, how much money did we spend totally on our tickets? Wait. How much total did we spend on our tickets? Total ticket sales were $164. Again, we are going to get to writing your equations, but to me, this is a really nice elimination. And like on the quiz, a lot of you didn't multiply one of your equations. If you would multiply this one by -1, you would have had this new equation where all of these would be negative. And when I subtract, I would have had 1.5A. And these S's would have canceled. And 164 minus 101 gives me 63. And please on your calculators right now, take 63 and divide it by 1.5. My adult tickets that I sold. What'd you get, Johnson? How much? 42. So I had 42 adult tickets. And now the easiest one to me is to subtract out from 101, right? Because we know the adult plus the student had to be 101. So I'm going to take 101 and subtract 42, and that's going to tell me how many student tickets I have, right? So I had 59 student tickets, right? We actually saw this exact problem in our notes before. Only thing it was in a story problem. So we did the same one when we started our elimination. It just wasn't a story problem. So when you're doing these, substitution or elimination are going to be ways that you can use to solve these. So as we take a look at this homework, we've already done number 1, right? Well, I am passing back the quiz, trying to get 2, 3, 4. We're going to look at 2, 3, 4, and 5 before the end of the period, okay?